I had number 3 for presentation 9, which said A has 2 identical rows, then delta n A equals 0. So I had a tough time grasping my head around the hint and basically the proof in general. I knew how to do this proof in another way, so I'm going to show you what I was thinking at first to basically back up my proof, and then I'm going to show you the proof that I'm not super confident in. So, of course, we know that A is a square matrix, and that will have 2 identical rows. So what I did is I just made up my own matrix using A, B, C, and then D, E, F. And I have my 2 rows that are the same. So if we want to figure out the determinant of this, you take our A on the top, and then we figure out the determinant between B, C, and E, F, which gives us A, B, F minus C. Now we do this just using now B, and now we end up using A, D, and CF. We alternate with our signs, so this one would be a negative. And then we finish it off with the last one. So we're trying to find the determinant, and this is how you find the determinant of a matrix. So now that we have here, we have our alternating signs, our minus then our plus. Now we can distribute what's in front. So we end up with ABF minus ACE minus ABF plus BCD and plus ACE minus BCD. So now a bunch of these cancel out. The ABF and ABF cancel out. The ACE and the ACE cancel out, and our BCD and our BCD cancel out. So this proves that the determinant of A is equal to 0, or delta n of A equals 0. So I knew that this was true, and now I had to somehow get this into a proof using my hint. And this was the best I could do, so just bear with me. So the first thing I did was I supposed that row I and row J of A are identical, just like how we had in our matrix. So now we're going to assume that the characteristic of F is other than 2. So that means it would only have the 2 identical rows. So our A would just equal EIJ A. So delta n of A is equal to delta n of EIJ A. So then we can say negative delta n of A. So because all 3 of those things happen, we know that the delta n of A has to equal 0. So the determinant of A is equal to 0. Now, what if our characteristic equals 2? if the characteristic of f equals 2, then delta n of A equals delta n of Eij negative 1A and we know that Eij negative 1A is a matrix that has a row of all zeros. So now by proposition 11.2, we know that the delta n of A equals 0. Thus, by both cases, we know that delta n of A must equal 0.